Legendre's linear differential equation. This is a form of Legendre linear equation. It will be the form ax plus b power n d power n y divided by dx square plus ax plus b power n minus 1 d power n minus 1 y dx power n minus 1 plus etc. Finally end with y equal to right hand side the function of x. If you find the differential equation in this form, we have to use the substitution method to fill the right hand side. We have to take let log ax plus b equal to z, rise to the power e on both sides. So e power z equal to e power log ax plus b. E power log x can be written as x. So e power log ax plus b can be written as ax plus b. So ax plus b. From that you have to find x value. So bring ax right hand side, bring this left hand right side. So it will become a power ax equal to e power z minus b. We need x value. So x equal to bring this denominator e power z minus b divided by a. So this is applicable for the right hand side. Next we will convert this equation with the variable coefficient into constant coefficient. Follow this way. Wherever you find ax plus b d, we have to apply a d dash, and ax plus b the whole square d square, we have to apply a square d dash minus 1. This a means coefficient of x. We never bother about b, but we have to take a from where? Coefficient of x. So like that ax plus b the whole cube b cube, a cube d dash minus 1 d dash minus 2. So it's a similar type as previous problem we had taken, that is Euler's method. Same process here we have to follow, but the only change is there the variable will be of the form x power n. Here the form is ax plus b power n. This is the only one change. So the changes are given here clearly. So make notes these things, and while solving the problem use these notes. Okay, I will completed that, put inside the box as a note. Okay, rest of the things we have to follow type 1 type 2 process only. Okay, write a problem, still bring. All of you listen. This is a Legendre type. We know that what is y double dash? D square y by dx square. Y double dash represents d square y by dx square. What about y dash? dy by dx. dy by dx. Okay. So just apply the values here. 2x plus 3 whole square d square y by dx square minus 2x plus 3 dy by dx minus 12y equal to 6x. Next, instead of d square by dx square we can apply in first type itself I told d square. So 2x plus 3 the whole square d square y minus, instead of d by dx we can apply d, 2x plus 3 into d y minus 12y equal to 6x. So which is a common term? Y is a common, so take it outside. So 2x plus 3 the whole square into d square minus 2x plus 3 d minus 12 into y equal to 6x. So first we have to convert this term into the constant coefficient. How? See the note. We have to apply the values. Instead of 2x plus 3d we can apply. Here what is the a? Here what is the a? Just look at the coefficient of x. What is the a? 2. So 2 into d dash. 2 into d dash. Never mind b. Here what is b? 3. Okay, never mind b. So instead of this we can apply 2 d dash. Suppose here 3x given means 3 d dash, minus 3x given means minus 3 d dash, minus 3 d dash. Okay, next 2x plus 3 the whole square d square can be written as Here what is the a? 2. A square. Here first we have to write a square. So get 2. So 2 square d dash minus 1. So just refer the note. Okay. So 2 square can be written as 4. So 4 d dash minus 1. 4 d dash minus 1. Okay. Clear that. Next. So these two substitutions here we have to use to convert this term into constant coefficient. Then right side application we have to do. Here x is there. So let 2x plus 3 2x plus 3 equal to log z. 2x plus 3 equal to log z or log 2x plus 3. Sorry, log 2x plus 3. See the note? Log 2x plus 3 equal to z. I think so. Is it not? Correct it. Let z equal to log 2x plus 3. Okay. Then what about e power z? What about e power z? E power z equal to e power log 2x plus 3. So e power log 2x plus 3 can be written as 2x plus 3. 2x plus 3. E power log 2x plus 3 can be written as 2x plus 3. So these are all the basic concepts. Learn that. Okay. Next we read x. So bring 3 left hand side. So 2x equal to e power z minus 3. So x equal to e power z minus 3 divided by 2. So we need x. So substitute all the values here. We will get, simplify this also, 4 d dash squared minus d dash. What we will get? 4 d dash squared minus 4 d dash. Okay. Multiple 4 d dash inside the bracket. So we will get 4 d dash square minus 4 d dash. So apply the values. Next. Instead of which one? This one we can write 4 d dash square minus 4 d dash. Take it as 1. Sub all values in 1. So instead of this value we can write 4 d dash square minus 4 d dash. Instead of this we can write next minus, instead of 2x plus 3d, we can write 2 d dash. Okay, 2 d dash. So 2 d dash minus 12 into y equal to 6 into. What about x? What is the value of x? E power z minus 3 divided by 2. E power z minus 3 divided by 2. If you have any doubt, you can ask me. Okay. Just we substitute the value here. We converted that into the constant coefficient. Differential equation into the constant coefficient. Can you find any variable here? Variable means x term here. No. So the constant term is there. Next we will simplify. 4 d dash square minus 4 d dash minus 2 d dash minus 6 d dash minus 12 to y equal to 6 into, we can cancel 3. So 3 into e power z minus 3. Okay. Here which term is common? Which one is common? 2 is common. Take it outside. So 2 d dash square minus 3 d dash minus 6 y equal to 3 e power z minus 3. Bring 2 left hand side. So 2 d dash square minus 3d dash minus 6 into y equal to 3 by 2 e power z minus 3. E power z minus 3. Okay. So we converted variable coefficient into constant coefficient. D dash square represent d square z by dy square, so dx square. Okay, because the notation is we converted everything into z. Okay, so d dash represents d by dz, sorry, d by dz, d by dz. What about d dash square? D square by d z square. Okay, we converted variable coefficient into constant coefficient by using the substitution method. Okay, next. So these are things we got. Next we have to simplify. First we have to calculate the complementary function. So method of calculating complementary function. Complementary function we have to calculate. So put d dash by m. Wherever you find d dash, you have to put m. So take this one. Instead of d dash, we have to put m. So 2m square minus 3m minus 6 equal to 0. We have to put d dash by m and equal to 0. Next, what is the highest power? 2. By using calculator, we have to calculate the value of m. Okay, all of you take the calculator and find the values. Still. If you solve this one, we will get two different answers, m1 and m2. If two answers are roots are different, then what is the complementary function? Complementary function equal to two roots are different. What is the complementary function? A e power m1x. What is m1? 2.64. Here instead of x, what should we have to put? Here instead of x, what should we have to put? Z, because we converted that into z. So z. Next, plus b into e power minus 1.14 z. So this is a complementary function. This is a complementary function. Next we have to find particular integral. Don't write, just listen. Don't write, just listen. Particular integral. So listen. In right hand side there are two terms are there. What are they? E power z. Another one thing, minus 3. Minus 3. 3 by 2 is a constant term. Keep it separately. 1 by, first particular integral 1. We have to find a particular integral. They go and stand there. Particular integral 1 and particular integral 2. This is a particular integral 1. This is a particular integral 2. First we have to calculate particular integral 1. So what is that? E power z. We can write this one multiple 3 by 2 inside the bracket. 3 by 2 e power z minus 9 by 2. Like that also we can split. So this is a particular integral 1. This is a particular integral 2. So first we have to calculate particular integral 1. 1 divided by 2 d dash square, 2 d dash square minus 3 d dash minus 3 d dash minus 6 into, first we have to calculate particular integral 1. So 3 by 2 e power z. 3 by 2 e power z. So it follows type 1. In type 1 we have seen e power nx, e power nx. Here instead of x, z is there. Instead of n, 1 is there. So we have to replace d dash by, here the 1. So 1. Suppose e power 2z means d dash by 2. e power 3z means d dash by 3. Okay, so we have to replace. So the particular integral 1 will become 3 by 2 is a constant term, so bring right side, because there is no operation based on 3 by 2, so bring right side. Okay, next 1 by 2 into what is d dash? D dash 1. So 1 square minus 3 into 1 minus 6 into e power z. So 3 by 2 e power z, because that's operation is over, so write like this, e power z. So calculate it. 2 minus 3 minus 6, what's the value? Minus 7, minus 7, minus 7. So particular integral 1 equal to minus 3 by 14 e power z. This is a particular integral. Okay, just to simplify this, 2 minus 3 minus 6. So minus 9 plus 2. What is the value? Minus 7. So minus 7. So 2 is there. 2 into minus 7, 14. This is the particular integral 1. Next we have to calculate particular integral 2. 1 divided by 2 d dash square minus d dash, sorry, minus 3 d dash minus 6. Listen carefully. Here one term is there, 9 by 2. If constant alone comes means which one is hidden? E power 0 z is hidden. What is e power 0? 1. So e power 0 z value 1. So e power 0 is hidden. So e power, so 9 by 2 e power 0 z equal to replace d dash by 0. Replace d dash by 0. So equal to, bring 9 by 2 right side, e power 0 z divided by, instead of d dash we have to put 0, 0, 0. So what about remaining value? 2 into 0 minus 3 into 0 minus 6. So equal to 9 by 2 e power 0 z divided by minus 6. So if we cancel these two, we will get 3 is a 2. So particular integral 2 equal to 3 e power 0 z. You should no need to write 0 z because e power 0 value is 1. So 3 by minus is there, minus 3 by 2, minus 3 by 2. Okay, so this is a particular integral 1, this is a particular integral 2. Next, here minus symbol is there. So what is the particular integral? Particular integral 1 minus, here minus is there, no, so minus particular integral 2. Divide it out. Okay, very good. So 2 into 2, 4. Okay, one correction. 2 into 2, 4. So minus 3 by 4. So this is a minus 3 by 4. So particular integral 1. Another one is particular integral 2. So what is the general particular integral? We have to add this. But here what is the symbol? Minus. So minus. Suppose here plus means particular integral 1 plus particular integral 2. Minus means we have to minus. Okay. Just to copy down, I will teach you. Then particular integral 2, sorry, particular integral equal to particular integral 1. Listen, here minus is there, so minus particular integral 2. Suppose here plus means you have to write plus. So what about particular integral 1? What is 1? Minus 3 by 14 e power z. Minus 3 by 14 e power z. Minus, what is particular integral 2? Minus 3 by 4. Minus 3 by 4. So minus into minus will be a plus. So particular integral equal to, bring positive first, 3 by 4 minus 3 by 14 e power z. This is a particular integral. Take it as 4. Next, general solution. General solution. Y equal to complementary function plus particular integral. What is the complementary function? What is the complementary function? A e power 2.64 z. A e power 2.64 z plus b e power minus 1.14 z plus what is the complementary function? 3 by 4 minus 3 by 14 e power z. So this is in z form. We will convert that into x form. So how will you convert? Instead of e power z, we can write what we can write? Log ax plus b. Here what is ax plus b? 2x plus what is b? 3. Listen carefully. E power z can be written as like this. What about instead of z we can apply log 2x plus 3. What about here? E power 2.64 z. Okay, e power 2.64 z. So what about e power z? E power z can be written as 2x plus 3. So what about e power 2.64 z? E power 6.z. E power z can be written as like this. E power 2z can be written as in first type, that is Euler's type. E power z can be written as x. Is it not? E power 2z can be written as x square. E power 3z can be written as. So this constant will come in the power. This constant will come in the power. Okay. So e power 2.64 z can be written as 2x plus 3 power 2.64. Okay, just till. Don't go that much level. Simply apply wherever you find z. Simply apply log 2x plus 3. Okay. So equal to a into e power 2.64 instead of z. What should we have to apply? Log 2x plus 3 plus b e power minus 1.14 instead of z we can apply log 2x plus 3 plus 3 by 4 minus 3 by 14 e power log 2x plus 3. We can stop with this. We converted z into x. Okay, this is a general solution. Complete it. This is a general solution. Complete it. In next step, we can apply the values. Okay, or we can stop with this. Both are correct. Okay.